Okay, good morning, everybody. We are here for this second session of this workshop on science and space diplomacy. Today, we have two intervention dedicated to Earth observation and my introduction about the PhD national program. This one, that one. I hope that you see my slide. Okay. This is two intervention coming from the two PhD students just arrived in our curriculum 7. But I think they are very interesting because this is a sort of experiment for our diplomacy, our methodology, but also diplomacy. Methodology because we use an interdisciplinary approach, a real interdisciplinary approach, because Andrea Tullj is a specialist, an engineer, coming to work with Sebastiano. Sebastiano is a political science student. Altogether work for two articles about Earth observation. They will present their subject, but the methodology is very, very interesting because they speak different languages. For this reason, they are obliged also to make diplomacy. It's not easy, but they may realize a sort of challenge, this complementary research coming from the technoscience side and the political science side. Very important. And frankly speaking, for me, it was a pleasure, a very good opportunity when Roberto Battiston, the coordinator of our PhD national program, Space Science and Technology, called me to suggest to open a curriculum number 7, dedicated for the first time in Italy, and also one of the few examples around the world about economy, okay, law, okay, space, but also space diplomacy. We were lucky because we started with a first PhD student, Dr. Piero Messina, and then we had two other PhD students coming from the European Space Agency with a special convention negotiated between the agency and the University of Trento. And then, thanks to my colleagues, in particular Domenico Capolongo and Maria Gagliardi, but also Professor Andrea Taramelli, we arrived to get some bourses for the PhD student. Last but not least, in the last academic year, Italian Space Agency accepted to finance in my research project a PhD student, in particular Sebastiano Ongaro. Today I want to underline why, and also to underline the opportunity for my discipline that you may see here. The previous name, SPS 06, History of International Relations, the opportunity for my discipline to participate in this PhD program, because I am an historian, but an historian coming from political science, and for this reason we are obliged. For us, it's also a passion, a pleasure, and is our work as historian of international relations to stay connected with the present day. We are historians, we make history, but we must try to design some tracks, some trends, to suggest elements, reflections, suggestions for analyzing a present day. But the most relevant condition in our PhD program, and as you will see in other field of research, when we speak about science and technology and foreign policy, is to have an interdisciplinary approach. For me, it was relevant to stay in CISAS, in the center of Padova University for space activities, created at the beginning of 1990s, just when in 1988 Italian Space Agency was born. And this center was born, created by professors coming from different disciplines, also geology. My chief at the time, Professor Antonio Varsori, suggested me to enter in this center as a representative of the human and political science discipline of Padua. The director was Professor Piero Benvenuti. I invite you to see the role in the past years and today of Piero Benvenuti, one of the most relevant astronomers in Italy and at international level. Then the next director was Stefano Dubey. Stefano Dubey is not with us today, he's dead, but for me it was a very, very important colleague. Why? Because he invited me to participate with the CISAS in this project, Horizon 2020, inside, inventing. The principal investigator was Pascal Griset, an historian of technology. And frankly speaking, when I suggested also to my department, to my colleagues, that I will participate in this project, the first reaction was a little esoteric. Why? Because it was very, very strange. But thanks also to Professor Debey, I was very convinced to participate in, and we got this very important special turning point, not only for my career. Today we have the European Union Space Science Diplomacy Alliance, this network of academics linked to the European Commission, and I was there. This is very interesting, very important. Last but not least, the last director is Giampiero Piotto, another astronomer, and thanks to Piotto suggested Roberto Battiston to invite me in this PhD program, and with Piotto and also with other colleagues, we organized several conferences on Bepi Giuseppe Colombo, one of the most specialists of space activities in Italy, very known in USA and in Europe, less in Italy. And I invite you to see the theater play that I coordinate is on YouTube about this special scientist. Last but not least, we arrived to create in the last week this observatory on space diplomacy in Ity, starting from history and international history. Several colleagues participate in this observatory, not only historians, but also scientists, engineers, etc., etc., and some Italian historian interested to science and technology, like, for instance, Mauro Elli from the University of Milan, in contemporary history in Italy as discipline, interested to the interconnection between science, technology, and foreign policy. In the meantime, my discipline was represented in a new project, the International School on Science and Diplomacy, launched in Erice at Ettore Majorana Foundation. I invite you to see the edition of 2024, thanks to this website that we open online, and which are the partners in this school and I director. I must thank two colleagues came in from neutrons science, Roberto Caciuffo, and particularly Professor Carla Andreani, because they are directors of an international school on neutrons, and they invited me to organize a week on science diplomacy just in May 2023, and they invite me to write to Professor Zichichi to create this school with Pascal Griset as director, the president of the Italian CASD, the Center for High Studies of head of international relations at CNR, and the last but not least, Ambassador Umberto Battani, the president of VIU, and a very relevant witness for Italian science diplomacy. All these, not the movement, but my interest came from, as I said, the interconnection between science, or particularly technology, and foreign policy. I put my book from my PhD thesis, but above all, Diplomatie utile militaire, this very nice book. The author are Jean Doise for modern history and Professor Maurice Weiss. Maurice Weiss with Georges-Henri Soutou in France is one. They are the best specialists for history of international relations. I invite you to see these books. They are about history, and particularly my book on interwar period and Soviet Russia, but they suggest which are the actors and the dynamics in this diplomacy interested to innovation, to technology, or national governments. We have here the director of the Botanic Garden in London, Professor Sally Zuckerman. His papers are in the history a science advisor, not the Italian government. Why these scientists are relevant? Because they are the link between science and political decision maker. And this relation is not easy always. As Richard Crossman said in 1960s, for a politicians, it was impossible to take a decision about science and technology because they don't understand anything. No, the correct reply was by Sally Zuckerman. They don't take time to understand. They don't care sometimes the relationship with expert and to construct some bridges. Like I and another very special colleague from University of Bordeaux, Christine Bounot, we organized a conference about expertise and society in Europe. Why? Because also in the European context, and particularly in European Union, the relationship with the experts is very, very strategic. And this relationship must be organized, created, organized, constructed. For this reason, yesterday and today, we invited one of the, frankly speaking, most prepared specialists in international relations in the simulation about European Commission and scientists, Dr. Shendikova, to experiment this interconnection. How this interconnection is relevant, you may see in the 3 books. You have the 2 first books. In the 3 books about the history of European Union Commission, started by another very important colleague and a very special professor for me, Michel Dumoulin, a real specialist of European integration history, also with 2 other French colleagues, Eric Bussière, a great specialist for economic international relations, and Sylvain Schirman, director of Robert Schuman Foundation and a specialist of Franco-German relations. In these books, we have also the 3rd book where I participate for transport policy, and also with a part about Galileo, the European satellites system. In these books, you have only 1 chapter about research and technology. As you see this chapter, the co-author is Eric Bussière, but also Arte van Laer, at the time a young researcher interested in science technology research in EEC, in the European Economic Community. We have only 1 chapter and we have only a few articles. Recently, this year, the Journal of European Integration History, the most relevant scientific journal on the history of European integration, had a special number, edited by the young German colleagues, on science and the European integration. Very interesting, but in this number, they don't remember a book edited by me, by Professor Barsori, and by another colleague, very important for me, Christophe Bunot, from the University of Bordeaux, about the interconnection of science, technology, and European construction process. Why construction and not integration? Because since the beginning, technology was outside the European Common Framework, the European Economic Community. Why? Because for the member state, we have in mind France, Western Germany, but also Italy, and then since 1973, UK, science and technology were strategic field of national sovereignty. For this reason, they wanted to have the maximum freedom for maneuvering for international cooperation. And also today we have some example of this. One of these is Arctic. Space activities are linked for Arctic. I remember only one reason, but we have several reasons. And first of all, the Earth observation and the SAR observation. And this morning you will have several information about this from my 2 colleagues after me. But there we have also one of the most important satellite data reception company, KSAT. And this is the opportunity for me to recall also another very important, brilliant colleague coming from the University of Trento, who invited me to Arctic conference and also to go in Svalbard Island, Professor Rasmus Gedeons Bertelsen. I call him always Rasmus, but he's Rasmus Bertelsen, a real specialist about Arctic. This is also an invitation when we speak about space diplomacy, and also in our PhD program, we must have in mind that is an error, is a fake approach to study only space. In particular for space. Space is the fourth dimension of human exploration. Dr. Tullj knows well, after ocean, after Earth, after sky, where several science and technology are engaged, first of all. And second, where, as a sort of mirror, the geopolitical situation of Earth is projected on space, not only in the satellite system, but also in space exploration. But generally, when we speak about science diplomacy or space diplomacy, we must have our field of specialization. For me was aeronautics and then space, but also to have interest for the other field of science and technology. Why? Because also in the other field, you have here the panel organized by Italian government in the last year, in the last Arctic conference. You have two major international conferences about Arctic. One is Arctic Frontiers in Tromsø, when I participate thanks to Rasmus. And the other one is in Reykjavik, when I organized, and you have the video on our website, Science Diplomacy Italy, I organized with several colleagues from Padova a panel about science diplomacy in Italy and Arctic. I invite you to see the video. It's only 50 minutes, but you have an idea of our approach. There is very nice, this panel, because you have the Italian ambassador in Oslo in charge for Arctic. You have a representative from the Italian Minister of University and Research. You have the president, Madam Carrozza of Senahar. You have a Italian Navy commander in charge of the Italian Institute for Oceanography. You have a representative of the Italian INFN, Italian National Institute for Nuclear Physics, and last but not least, a representative of ISPRA. You have scientists, you have politicians, you have diplomats. You have in this panel all the people engaged in science diplomacy. And it's very interesting because we have the same type of peoples also in space diplomacy. For this reason, it's very interesting, not only, I repeat, to be interested to space, but also to other fields of research in science and technology. For this reason, I and Marilena Gala, thanks to the suggestion of another colleague, Lucia Coppolaro, they invite me to participate in a call, Italian call, FISR, the name, and I got a research project to launch in 2021 the first Italian school on science diplomacy. The name was Ex-Post Team. Expert, politicians, and science technology. Team diplomacy. Why team? Because I apologize, I am sorry, but we must stay all together to study and to practice this diplomacy. It's impossible for a diplomat without the participation of scientists and also for scientists. And above all, we want to share with our student knowledge, memory, the history, but also the practice, and to use spring schools in presence. This invited us to launch, thanks to collaboration, we have several projects in collaboration with the Historical Archives of European Union in Florence. And I have to thank so much the director, Dr. Dieter Schlenker, but also the vice director, today retired, Gerardo Bonini. Gerardo was in charge in 1987 when in charge of the management of the European Space Agency archives. When these archives arrive, thanks to a research project launched by two historians, John Krieg and Lorenza Sebesta, and Arturo Russo, a scientist, to study the beginning of European Space Agency. In our work, it's very important to remember our previous colleague. And for this reason, we launch this new series in oral history on techno-science diplomacy. The idea to have, the history, practice, but also witness of recent time, like, for instance, Ambassador Vattani. You have several videos by Umberto Vattani in our website that you may see, but you have also other witness. The most relevant point is the archival resources and documents. You have here a photo about one of the unique Italian Minister of Science and Research studied at the moment, Luigi Granelli. Why? Because Luigi Granelli left his archives in Istituto Sturzo in Rome, the archival institute of the Catholic Democratic Party in Rome. This is to underline that private archives are relevant. With some witness, we arrive to invite them to give their archives to the historical archives of European Union. Why there? Because not only in Italy, but also in Europe, they have a real important experience in the management of several types of archives, not only the institutional archives, but also the European Space Agency archives, the European Science Foundation, and several papers from individuals. This is very important, this complex approach to understand, for instance, history of European integration from another point of view. I quoted several times this example. We have this example by Altiero Spinelli. Altiero Spinelli launched a plan for aeronautics policy. As I said in my lesson, in microelectronics and geopolitics with Alessandro Paccagnella, this idea of Altiero Spinelli was not only for aircraft. And today, thanks to several research, we have the proof that at the same time, they had the idea to extend this proposal for a coordinated policy in the European community, not only for aircraft, but also for microelectronics, and then also for aerospace. But, as I said at the beginning, the European government refused this approach, and as said Roland Dumas, the Minister for European Affairs and then for Foreign Affairs of the French President Mitterrand, these governments had in mind to organize intergovernmental cooperation outside the European community framework. Why? As I said, because science and technology are strategic for the national foreign policy. These underline a real limits that we had in European construction, not only from the political side, but also because we have no industrial policy, we have no innovation policy. And now we have an intergovernmental approach, not a common approach to this strategic policy. And you may see this today in the present debate about defense policy. But we may hope that science is useful also to construct Europe. And I finish with this example suggested me by Carla Andreani and Roberto Caciuffo, scientists of neutrons, and I suggest you to see this European network outside the path, the way of the European integration, but a real European infrastructure for research in Europe about neutrons. It's very interesting because we are able to present the story of these networks thanks to archival documents, thanks to scientific papers, last but not least, thanks to the witness of several actors like Carlo Andreani or Roberto Caciuffo or other colleagues came in from all these countries. I finish here. This is to say that Europe is constructed also outside the European Union institutions, and science and technology, scientists and politicians engaged in this cooperation, they are relevant actors for this construction. Thanks so much. And now I give the floor to Dr. Andrea Tullj and then to Sebastiano. If you have some question, please, for the end of this second session of our workshop. Vi ringrazio per l'attenzione. Prego. Grazie.
Vediamo se funziona così. No. Sì. Allora, questo lo possiamo chiudere.
E prende le sue.
Vediamo se funziona così.
Yes.
Yes. Okay. Ottimo. So thank you for being here today. My name is Andrea Tullj and I am a doctoral student at the 40th cycle of the SST doctoral program at the University of Trento. Okay, in this presentation, we will discuss the importance of Earth observation, examining the history and technology behind the satellite and sensors used. We will delve into the practical application of this data, from weather forecast to agriculture. Imagine being able to see our planet from hundreds of kilometers high. Today, we will explore how satellites allow us to do just that, observing Earth to better understand our world, manage resources, and address global challenges. We will see the significant advances of this technology over the last 50 years and this concrete impact. But what is all this information for? They are used to understand the complex mechanism of our planet. They are essential to substantially managing vital resources such as drinking water, forest, and farmland. In addition, they are crucial for monitoring and responding to major challenges such as climate change, predicting and managing natural disasters such as floods or fires. This timeline here in this slide highlights several significant milestones, from the launch of Sputnik 1 to the advancement brought by today's Earth observation satellites. Each key point showcases how satellite technology evolved, enabling comprehensive monitoring of our planet's environment and weather patterns. The beginning of space age marked a radical change in technological process. The space race in the late 50s and 60s was driven by the geopolitical competition, but it also laid the foundation and groundwork for Earth observation. The launch of Sputnik 1 by the Soviet Union in 1957 marked the beginning of the space race and demonstrated the possibility of artificial satellites. Explorer 1, the first American satellite, followed in 1958 and made the first scientific discovery by identifying the Van Allen radiation belt. Although initially not intended for Earth observation, these early missions demonstrate the technology and the infrastructure for future applications. The first satellite explicitly designed for Earth observation was the Vanguard 2, launched in 1959 by the United States. Although it had technical issues after launch, its purpose was to measure cloud cover. TIROS 1 in the 1960, is often considered the first successful weather satellite, providing the first television images of weather conditions from space. This was an important milestone in weather forecasting. These early satellites mainly use optical sensors, essentially cameras, to capture images of the Earth. Here on the right, you can see one of these images. Here are presented some Earth observation satellites developed and operate in Europe. Examples are the Meteosat first generation that was placed in a geosynchronous orbit around 30,000 kilometers above the equator. SPOT, a commercial Earth imaging satellite from CNES, the French space agency, and ERS, European Remote Sensing Satellite, the European Space Agency first Earth observation satellite, placed in a polar orbit. So as we said, ESA has been dedicated to observing Earth from space ever since the launch of Earth's first Meteosat weather satellite back in 1977. With the launch of a range of satellites over the last 40 years, we are better placed to understand the complexities of our planet, particularly with respect to global change. Today's satellites are used to forecast the weather, answer important Earth science questions, provide essential information to improve agricultural practice, maritime safety, and help when disaster strikes. We will now discuss the different sensors that can be installed on a satellite, such as the optical ones. Optical sensors are passive sensors, which means that they rely on natural light. mainly sunlight, reflected from Earth's surface. Different materials on Earth reflect different amounts of light at different wavelengths, creating unique spectral signatures. Optical sensors detect the intensity of reflected light across various wavelengths, and this is similar to how our eyes see the different colors, detecting the different wavelengths of light. Early optical sensors installed in satellites had relatively low spatial resolution, meaning that the smaller objects they could see clearly on the ground were quite large. For example, the Landsat 1 in 1972 had a resolution of about 70 meters. Over time, the spatial resolution has improved dramatically. Satellite launch in the late 20s and early 21st century could reach a resolution of less than 1 meter, allowing us to see much finer detail, such as individual buildings and cars. The development of panchromatic sensors, which capture a wide range of visible light, has resulted in higher spatial resolution, which are often used to improve the sharpness of multispectral images that we will now see. Multispectral sensors go beyond simply capturing the red, green, and blue light like a regular camera. They capture data in several wider bands across the electromagnetic spectrum, including infrared, and ultraviolet. The first big step was the use of multispectral sensor in the 60s, partly driven by the declassification of military technology. Landsat 1 in 1972 carried the multispectral scanner MSS, which recorded data in 4 spectral bands, including visible and near infrared. The Landsat program has been a cornerstone of multispectral Earth observation for decades. The French Spot satellite also contributed significantly with higher spatial resolution in their multispectral sensors. More recently, the Copernicus satellite Sentinel #2 provides high-resolution multispectral images with 13 spectral bands. Application includes precision agriculture, optimizing irrigation and fertilization, environmental monitoring, tracking pollution and deforestation, mineral exploration, disaster response, and even climate change research on greenhouse gas monitoring, for example. Hyperspectral sensors take the multispectral imaging to the next level by capturing data in hundreds of very narrow and continuous spectral bands across the electromagnetic spectrum. While the multispectral may have 5 to 20 bands, the hyperspectral may have hundreds, even thousands of different bands. This creates a detailed spectral fingerprint for each pixel in the image. This fine spectral resolution allows the identification and quantification of chemicals and physical properties of Earth on Earth's surface. This can be used to identify specific minerals, plant species, soil composition, water quality parameters, and even detect pollutants. This is from space. For example, hyperspectral imaging can distinguish between different types of trees, detect plant diseases early, or identify oil spills in the ocean. Early hyperspectral missions such as NASA EO1 Hyperion demonstrated the potential of this technology. Current and future missions such as Germany HEMAP or Italy's PRISMA and the upcoming Copernicus Chi mission will provide more data and expand applications. We will now introduce the SAR sensor. The synthetic aperture radar is an active sensor, which means that it emits its own energy in the form of microwave, and it measures the reflected signal. By using the movement of the satellite in space to synthesize a larger antenna aperture, SAR can achieve higher spatial resolution even with a relatively small physical antenna. A major advance of SAR is the ability to image Earth regardless of weather conditions, so clouds, rain, fog, and at any time of the day, which can be day or night, because microwave can penetrate clouds and are not dependent on sunlight. This make this valuable for monitoring areas subjected to cloud cover or responding to events that occurs at night. SAR is crucial for disaster monitoring, we know very well in Italy, such as flood extent mapping, landslide detection, and damage assessed by after an earthquake, for example, as it can provide timely information even through the clouds. It is also essential for monitoring sea ice extent and its thickness, tracking iceberg, studying glaciers, and contributing significantly to the study of climate change. Early SAR satellites such as Europe ERS-1 and Canada RadarSat paved the way for current and future SAR missions. Copernicus Sentinel-1 mission provide freely available SAR data for a wide range of applications. But how do we turn data into knowledge? The exponential increase in computing power of the past 50 years has been crucial for processing the vast amount of data generated by Earth observation satellites. Sophisticated algorithms were developed to extract specific information from the data, such as identified land cover type, measuring vegetation index, detecting changes over time, and creating 3D models. The integration of artificial intelligence and machine learning is revolutionizing data analytics. AI and machine learning can automatically identify patterns, classify objects, and even predict future trends from the satellite data, making analysis faster and more efficient. The Copernicus program is a flagship program of the European Union, implemented in collaboration with the European Space Agency, ESA. The program aims to provide accurate, timely, and easily accessible information to environmental management and to understand and mitigate the effect of climate change and civil security. The Sentinel family of satellite goes from Sentinel-1 through Sentinel-5 to Sentinel-6, carries a range of advanced sensors, including optical instruments, multispectral, hyperspectral, radar, composition. A key aspect of Copernicus is its free and open data policy, which makes the large amount of high-quality Earth observation data freely available to users worldwide. On the Italian side, the Iride Italian constellation represents a significant advancement in Earth observation technology, providing higher resolution data. This initiative shows the effective collaboration between the Italian Space Agency and the European Space Agency. The constellation advanced sensors, which include both optical and radar capabilities, enable comprehensive data collection across various sectors. This multidimensional approach enhances our ability to monitor agriculture, security, and disaster management, ultimately supporting the informed decision-making by our politicians. To conclude, from the first simple snapshot to today's sophisticated multispectral, hyperspectral, and radar information, Earth observation from space has come a long way in the last 50 years. This progress has been fueled by relentless innovation in sensor technology and data processing techniques. This eye in the sky provides us with invaluable information about our planet, helping us monitoring itself, managing its resources, and respond to challenges we face. As we conclude, it's essential to recognize the dynamic nature of satellite observation, which continuously enhances our understanding of Earth. This evolution is not just technological, it plays a crucial role in monitoring environmental changes and informing policy decisions. Furthermore, international cooperation is vital in tackling pressing global challenges. By working together, nations can share data, resources, and strategies to create impactful solutions. Investing in technology and fostering collaboration will be key to ensuring a sustainable future for generations to come. Thank you for your attention. Thanks.
So first of all, thank you all for the attendance. I will also remember everyone to write their name in the chat and the surname in order to track the presence within the call. So, good morning, everyone. I am Sebastiano Ongaro. I am a PhD student in Curriculum 7 with supervisor Professor Burigana. My fellowship is covered by the Italian Space Agency, and my operative site is University of Padova. So, I am here to tell you a story about cooperation with a country that no longer exists, like Soviet Union, and the transition toward the new Russia. This is the index of my presentation. So first of all, we will have a timeline in relation to what are the main striking point of this cooperation path and the development that led to the situation that have today in relation toward the cooperation. So we will see until 1995 in order to do that, but this framework developed and entrusted until recent event that changed this framework. We will see the state of art, so the literature that we have over this topic, and we will see how the situation was for the Soviet state during 1985-1992. So the internal situation, the economical situation, and the international relation. All these things are the tool that led to cooperation with ESA. Then I will have a little excursus because Professor Burigana told yesterday and today many things about space diplomacy and science diplomacy, but we will use this little time to tell you and to understand how the juncture between Soviet Union and ESA developed. Then we will see the beginning of the path with the Soviet Union. In order to do that, we will see document from the archive of European Union. This document tell us the history of this development. Then we will move toward the case study of cooperation, ERS-1 and Almaz. These two satellites have a long history of cooperation between the two, and this is a really striking point of cooperation between ESA, Soviet Union, and then Russia, because this cooperation moved also after the dissolution of Soviet Union. Then we will have a little talk about the state of the relation nowadays, and we will have some timeline. So, in 1985, something changed in Russia. Gorbachev was elected as new Secretary General of the Communist Party of Soviet Union. So he changed some policy of Soviet Union that we will see later. Many of the students that we have in presence are students from international relations, so they knew many of this information. But we will understand the path that brought to cooperation with ESA also. Between 1985 and 1991, we have a striking cooperation. So they began to enlarge the agreement, the cooperation, the memorandum of understanding between the two countries. And in 1991, 1992, we have this experiment, this cooperation between these two satellites. In 1994, we have a big agreement between Soviet Union and Russia. We have Russia in 1994, and ESA in relation toward main flight and the associated space transport system. So, the state of art. We have a literature over the topic of cooperation. The first book that I would like to underline is 50 Years of Cooperation in Space, written by Professor John Craig. This book tells us the story of cooperation in space in relation to ESA, and also tell us how the development is a really important book text for understanding all this movement. Another book wrote by Professor Craig, Russo, and Sebastian is in relation to World History of European Space Agency. This book is wrote before the 50-year cooperation, but I put in second place because in between 85 and 87, as I told you, this cooperation became really strong. Last but not least, we have also the chapter from the book written by Professor Olga Dubrovina in relation to world space issues in Cold War and Central Eastern Europe. This tells about the cooperation within the Eastern Bloc. So, Soviet state at dawn at 90s. So, Gorbachev rise as a reformer. He wants to change what isn't working in Russia, move forward from the situation in which the Soviet state fall. He introduced some reform, but he is not the one with the objective to dismantle the Soviet system. He wanted to keep it up. So, two main reforms, perestroika and glasnost. Perestroika, an economy reconstruction. So, to reconstructing the economy of the Soviet state. Glasnost, to open the political debate, open the press, open all the situation in which the Soviet state remained during the period before him. But when you open a state that was closed for so many times, so open the diplomatic debate, the public debate, and so on and so forth, as you know, there is some inconvenience. So when the public debate became public as itself, they can criticize the regime. So one of the impacts of the glasnost was the impact on the regime. So the people criticized the regime. So discontent emerged within the Soviet Union, and some contradictions were pointed out by the people in relation to the system by itself. There is an erosion of the consensus of the party, because we have one party at the time, the Soviet Party. So they changed, there was a decline of confidence toward the Soviet Party, a growing disillusion toward the ideology, what the party represents in its development. This brought also the rise of tension between the different nationals that compose Soviet Union. For example, the Baltic state. As you know, in 1936, there was the aggression towards the Baltic state by Soviet Union and the annexion. So the majority of the population that was in the Baltic state was not ethnic Russia. And people demand freedom, demand their independence. But another important topic is economy. As you can see from this picture that I took in the archive, economy was a problem. The situation, the economical situation was really an issue. The economy was central planned. So centrally planned economy for all the different situations in which every single republic finds itself. Was a stagnant growth. So really was not the possibility to develop the economical system. A low productivity. So if you understand the fact that the plan direct the economical production, you have also a low productivity in the sector that was outside the plan, and shortage of goods that was not supposed to be important by the state. So perestroika had its own contradiction in the introduction of market element into the system that was still dominated by the state, led to a system that was not working well, was not going towards a development. This led to negative results in the short terms, declining of the industrial production and agriculture, increasing of public deficit, because if you must spend the money in order to maintain the system, and you have also a higher military spending, because Soviet Union, as you know, have this necessity also to spend a large chunk of the money towards the preparation for an eventual war within another country, within another bloc, they draw out all the money, so deficit. And there is also the expansion of the black market and the underground economy. Also, if you have underground economy, you don't pay taxes on it. So be clear. Social consequence. So the increasing shortage of basic necessity. We have really problem of production during this period. This is also led to unemployment, and also this case mean to conserve the Soviet Union as it was without reform. Gorbachev brought this new thinking that the logic of Cold War was the system, the things that brought to this stagnant situation. So he developed a new concept, cooperation side, in order to guarantee a better system, in order to attract the possibility of investment. Disarmament as a tool to reduce the military spending. So if we cut the armament, we have less to spend, and much more money will be developed and sent toward the internal situation, and the end of interventionism. Disarmament is really important. We have the NF Treaty in 1987 with the elimination of intermediate range nuclear missile. The openness to multilateral dialogue between different countries in order also to attract investment, but also to reduce the anti-Western rhetoric, in order to open it with. And also he reduced the control over Eastern Europe and Asia. So end of Brezhnev doctrine. No more intervention when a country moved outside from the Soviet ideology. We saw with Brezhnev the tanks that was rolling in some country. Also non-interference with the democratic movement in Eastern Europe. One can be told of Solidarność in Poland. They withdraw from Afghanistan. Brezhnev entangled Soviet Union in a war in the country that is called Tomb of the Empire, for a reason. And this war was not going well. They are losing tanks, troops, men, and money in particular that can be redirected towards the internal situation. So he began announce this retreat from Afghanistan operation, and he began to reduce the troop. The complete withdrawal was in 1989. This was really a costly war. The first conflict near the border of the Soviet Union, very near. And at the end, he appeared as a peacemaker, one man that is finding compromise with other countries in order to negotiate, in order to attract investment. In 1991, in August, we have an important event from the conservative part that I told you before, the push, the August push, when the conservative do a coup d'état in Moscow to take out Brezhnev from his seat and to bring back Soviet Union as it was. This coup failed because the people was not supporting this kind of position. And one man capitalized on it. His name was Boris Yeltsin. So this was the beginning of dissolution of Soviet Union. The event that began with the August push was the really event that brought to the dissolution that was completed in the evening between the 31 of December 1991 and the 1st of December 1st of January 1992. But the declaration of dissolution was on the 26th of December. Between space science and diplomacy, as I told you, economy is a tool. It's a tool for strengthening cooperation. Here I put a definition from Roberto della Cecca. He told us how space and the enterprise that work in space make diplomatic contact between them. So if a sector like space is intertwined between different industries that are divided by different countries, this is an open diplomatic channel. Open diplomatic channel is really important, and they can construct an intent between them. Also, I quote Professor Ruffini that told us in Science Diplomacy, a new dimension of international relations. In diplomacy, when other forms of dialogue are blocked, placing at the center of multilateral diplomacy to tackle global issues. So when the channels are closed, science diplomacy works as a tool to connect states. Professor Burigana told yesterday about Ettore Majorana. Ettore Majorana was this example, for example, when science became a diplomatic tool between the countries. The window toward the East. So we are speaking about ESA. 1970-1984, we have not so big agreement between Soviet Union and ESA. At the time in 1970, as you know, there was ESRO and ENDRO. The first agreement that I found in the archive at the moment was in February 1971. This document in which I took this information is really important because it's defining this first agreement as a satisfactory umbrella for future cooperation. So this umbrella is really important to cover the operation that ESA and the Academy of Science of Soviet Union intertwine between them. But this relation must be kept simple and informal. So not to overstress the system. ESA know what is working with people from the outer side. So they need to keep the relation really simple. Between 1985 and 1990, we have with the Gorbachev leadership a running of this cooperation, also because this means cooperation between economy, money moving from towards Soviet Union. This cooperation led as an instrument really important to develop all the system. And in particular, there is a development in relation towards Earth observation that became really an important topic, one of the first important topic of cooperation. And in this, we will move now, the case study. So, The cooperation between Soviet Union and ESA in relation to Earth observation is a long-standing cooperation in reality. Then was transferred to Soviet Union, from Soviet Union towards Russia. We will speak about a cooperation in relation towards the ocean wave monitoring. But as my colleague Andrea Tullj told you, there was other experiment like oil spillage. So, starting from that, we moved before. In August 1991, there was a controlled spillage in the Arctic Sea. In this kind of operation, these two same satellites were working together in order to find radar images over the oil spillage. It was a controlled one, so there was a tanker that left oil in the sea, and the satellite passed over to find this kind of leakage, and they found it. So the first cooperation was really a success. From this, they move on. So we have ERS-1, assisted aperture radar, and the ALMATS-1. These two satellites cooperate in order to find the Gulf Stream. The Gulf Stream is this batch of hot water that move from the Gulf of America, or Mexican Gulf, as you prefer to tell, towards Europe. This period of operation is between September and November 1991, but the data was shared in 1992 because there is the period of transition. So there is quite an issue inside Soviet Union. The mission to come was a success. They find the Gulf Stream and they find all this information related within this stream with these two satellites. So they combine the images in order to find this kind of information. This was a success, also because it developed even more the cooperation between Soviet Union and ESA, and subsequently Russia. As you can find in the document, it's very small, but I will read you. They speak about the cooperation over the Earth observation and the exchange of satellite data. If you think to Soviet Union, ALMATS, first of all, is a military satellite. It started as a military satellite. Do you think that it will be possible to share data from a military satellite? No. It's this opening that brought cooperation, that brought us here, technically. These are two documents. It's the same document, but it's 2 pages from 1992, from July. They speak about this cooperation. As my colleague told you, ice and sea monitoring, agriculture, forestry, geomorphology, and cartography are the main focus. So it's really important to understand how this cooperation entangled Soviet Union, Russia, with ESA, or diplomatic tool, not only by the point of diplomacy, but by the economic point of view. And this is a draft about, as you can see, technical characteristic. Sharing data about a satellite, a military satellite, before was impossible. So here we saw the document that tell us that ESA received some information about what they are working with ALMATS-1. So information that was secret before. But not every story had, after the invasion of Ukraine, but even before with the 2015 operation in Crimea, nowadays the relation between ESA and Russia are quite cold. Also, many joint missions were dumped because of that. Military operation in Ukraine led us here in the situation in which we find. So, conclusion is a story that tells us how ESA overcome a barrier, how the cooperation overcome a barrier between two states, Soviet Union and Russia later. So onward from 1985, this cooperation is really important in order to develop the system between ESA and Russia and ESA and Soviet Union before. But this cooperation was never so easy because there were little accidents in the past that led to this kind of cooperation. I haven't told you many problems that they will find only because we have a little time, but it's really important to understand why cooperation overcome a barrier. Thank you very much.
Okay, now we have about 10 minutes or 15 minutes for the question. If you have any question or if you have any question or remark. Because I want to ask you to prove your approach. I will make it where I probe satellite, but it's possible to see the photo with the photo with the design, the draft.
Yeah, indeed. So I will be brought back to the presentation in relation to the.
Se ho capito bene, all'alma, se un satellite.
Okay, my question is because when we stay in an archive, no, we discover this type of design, this image, this picture. If you are very, very curious, perhaps you arrive to understand what is, which are how it works. But in this case, we have immediately, when they stay all together, for instance, they passed some days in the historical archives of European Union and also in Esrin. Thanks also, we quote Dr. Pierre Kitchener, who is in charge in the European Space Agency of the archives. For instance, it's possible for Dr. Tullj to explain, for instance, we are in the archives, I discovered this design, I have Dr. Tullj with me, and we experimented how performing is Dr. Tullj to...
So I'm doing this in...
a sort of joke, perhaps a sad joke, but anyway...
Okay, so...
Because I have also another question, no? How it's possible, why, which was the system of SAR to discover the route of Gulf Stream? And then...
The question is easy, is the answer that is not easy. But
okay.
in any case, I will try to, let's say, okay, also the technical people will, I apologize in advance. What we see here is let's say, is the prospection on the Earth surface. So let's say the squares of a passage of a SAR satellite. So the satellite is this one in the, let's say,
yes,
here. I have also, yes, on the, so let's say the orbit is this dashed line. So the satellite is moving in this image from left to right. And, in this path, as we said in my presentation, SAR is an active instrument, which means that you have an antenna. The antenna is beaming on Earth an impulse, so several impulses of microwaves. These microwaves arrive to the Earth, they bounce on Earth's surface, and they go back to the satellite. In this very, let's say, tiny fraction of time that, let's say, the signal goes from the satellite to Earth and back. The satellite has moved. This is the reason why it's called synthetic aperture radar. It means that the antenna is not, let's say, a gigantic one, but let's say the aperture is given by the fact that the satellite is moving in space in its orbit. So what we see here is pretty much the, let's say, the projection on the Earth surface of the signal, of the impulse of radar microwaves sent by the satellite, bounce to the Earth and back to the satellite, which means that the satellite can pretty much explore with this pulse this area here in the dashed.
But only the surface of the, or the idea of this design is that it's possible to see under the surface.
Okay,
because this is interesting, no? At the time we had the possibility to make photo, no? The recognition photos started during the First World War. The 3D, three-dimensional photos started in the First World War in the Dolomites, thanks to an astronomer, very famous. The name was Abetti, George Abetti. He was the professor of Margherita, and he was in charge as a young lieutenant of a special squad to make 3D, three-dimensional photo, to explain to big generals that when you fight in mountains, it's not only relevant the map, but also the height and the three dimension, and to discover what you may have behind, no, the mountains. But here we have the SAR, and with the SAR, I think the great idea was to see under the surface.
One of the things that can be done, so for example, here the different dash line in these things is because you can use the SAR satellite with different modality, which means that you can take a very narrow strip or a larger strip with less detail. So depending on how you want really to use and you planify the mission, you can have different results. One of the things that can be done with SAR satellites, such as the Cosmos Sky, because SAR is something that is an Italian specialty. So we are very good in Italy, especially with the Thales, for example. We are very good at doing these kind of satellites.
This is a very important point to understand for a diplomat, which are our strong points in space activity.
So, for example, just in this case, the French are much better, or let's say they are good in doing optical satellites. So they have the, let's say, the technology of doing the lenses of the telescope. Instead, in Italy, and let's say, I can claim that this is one of the national excellence doing the SAR satellite. And we have a constellation called Cosmos Skymed. It is a dual-use constellation, so used by, let's say, the civil and military as well.
And when started the Cosmos Sky?
There are several satellites. One has been recently put out of mission. I don't remember the dates, but
in this case, Sebastiano now relaxed. You don't see the Sebastiano now in the web, but in this case, Sebastiano would give the answer when we have the launch of SkyMed.
Okay, in this case,
is an example, no, of our methodology.
Of cooperation, internal cooperation.
Yeah, it's very important.
One of the things that can be done, for example, with this satellite is when you have an earthquake. One of the slides that I was in my presentation showed one of the possible applications, which is called the interferometric SAR, or INSAR, which actually allows, with the complex process, but okay, in any case, by multiple passages of this SAR in different, let's say, passages, to understand the displacement of ground in terms of millimeters. So, for example, if they can be from satellite. So, for example, if there was an earthquake, you can clearly see where the soil, where the ground moved up and down. You can see the line in which there was a sliding.
And my question for you is also, in the case of the whale in the ocean, it's possible also to see the whale.
The wake of the ships, you mean?
Yeah, the whale, the balene.
Le balene. The whale, I don't know. I know that there's a wake, So for example, if you have an object like a ship passing, you can
this was my second question.
Indirectly tracking.
I was obliged to taste whale in Svalbard Island, but also because, for instance, submarine.
Submarine, it's if they are not submerged, it can be done. I'm aware that the Chinese are moving in this direction for spotting the American satellites, but I'm not an expert in SAR. So
okay, but this is also an example, no, of the use, because it was also very interesting when you put the slide about the military release, military declassification of the materials.
Well, these things were born in for military applications. So, for example, it's very well known. Actually, it's a case of space diplomacy. Now that I'm thinking, there was a Soviet satellite, Cosmos something, that pretty much had a very powerful radar to track the U.S. Navy, and the satellite had such a powerful sensor that he was not relying on solar panels for, let's say, for energy, but he had a nuclear device on the satellite, so a nuclear thermoelectric generator. And this satellite had the problem, one of the satellites of this constellation had the problem, and it actually deorbited on Canada with a nuclear device on it. And so I think it was 72 or something like that, if I'm not mistaken. Yes, this was the first application of the Outer Space Treaty in which a country is, let's say, liable for the damages caused by, let's say, their own space asset. And the Soviet Union had to pay Canada like 3 million Canadian dollars for the Canadian to clean the, let's say, the radiation, the radioactive waste and the nuclear waste, yes, in a very remote zone of Canada. So yeah, this was a practical application of, let's say.
Which do you know which was the level of the details in 1960s or 1970s, when we have a real turning point in the optical satellites for military application, if it's possible.
The optical satellites, so passive satellites. Let's say the first application where, if I go by memory, I'm not an expert in these things, but if I go by memory, it was the Corona project by the United States. And these satellites had a film. So they were not the sensor that now we have on the camera of the phone, for example, here. These are, of course, electronic sensors. At the time, in the 60s, you didn't have this kind of sensor, so you had really a camera with the film.
And which was the system to get?
That's the important thing, because yeah, it was there was a fleet of aircraft with a special recovery device on top that were actually capturing a capsule that was sent from the satellite back to Earth.
1960.
Yeah, in the 60s. This was, let's say, the first ever attempt to have, let's say, it was contemporary to the U-2, let's say, airplane, which was a much riskier mission because you have to fly over the Soviet Union. Instead, with the satellite, you go there, you take picture. Then the problem was to recover actually the capsule. So you had this device was pretty much jettisoned from the satellite, re-enter the atmosphere. So it was
without parachute.
At the end, when it was in lower atmosphere, he had a parachute, and this thing was recovered by an aircraft. So there was a special aircraft with the special equipment for recovering this parachute and the film, and then the film was developed. This was before let's say, the development of the electronic sensors, and it was a major push for the electronic sensor development because in this way you don't have to recover the actual film, so from the camera on the satellite, but you can transmit the image. And this was a major push for it. Of course, let's say the major driver were the military, because the military had the need to see what's going on Earth. And actually, to give you an idea of the, let's say, the actual the performance, today we are talking about a resolution of 15 centimeters. So from a satellite, you can see something like this phone.
For military.
For military, yes.
Yeah. And I have a last question for both of you in these your articles about Russia and European cooperation. Do you think that you must take account also of this sort of rush to Russia knowledge by US and by European Space Agency. If you want to reply, but here, if you have any question, otherwise, with this reply, we finish.
I will tell what please. So we found the document. I can say that was some document with some criticism in the relation towards with the colleague from the other side of the Iron Curtain, we can say from Soviet Union. So in order to research that, you find personal note from diplomats from the office that are quite critical in the relation. I haven't put it in the presentation, but the relation, as I told in the end, was not really every time so beautiful. And the rush towards technology was really an issue because there was this after 85. So when there is the open, there is a rush of cooperation. Also, US try a bilateral approach with Soviet Union. The attempt is to took everything is possible in the shortest step possible. But Russians are good in this game also, and they attempt to keep the technology for themselves also. So it's like a game, cat and mouse. So it's a play between countries. The order is not to share everything, because if you share everything, you lose your power, you lose your capacity to negotiate, because you have no more teeth to do an aggression, to do a fight. I leave to Andrea. Yeah.
I just wanted to tell you, let's say, an experience from my life as a student, an engineering student at the University of California. San Diego, back in the States, pretty much created a visa program for researchers of the Soviet Union or Russia after to go to the United States and pretty much be naturalized in the United States. In this way, they created a big brain drain, of course, from people that were very, let's say, expert in the field. Russia and the Soviet Union had let's say, a peculiar tradition space. They had a very key, let's say, technology, for example, in metallurgy processing for the engines, for example, they are a master. So one of my professors at the University of California was a Russian, but several actually professors were from the Soviet Union Institute of something deep in Siberia somewhere. Very good professor. And another thing that I remember until very recently, that one of the let's say the launchers that the United States is using to access the space, I don't remember if it was an Atlas probably or Delta. Okay, I don't remember the specific launcher, but they use until very recently a Soviet-developed engine. So an American missile, let's say at the beginning of in the wake of the fall of the Soviet Union, was developed using an engine coming from the Soviet Union. So developed by the Soviet, which was bought by the Russian. They bought, let's say, a large quantity, and now the relationship are degraded. They have a problem because they don't have the supply of this engine any longer. So they're using the very last ones that they have, and then they have developed a new way to access space with SpaceX. Yeah, but okay, these are just, let's say, free talking if you want to interact. I don't know if you have other questions.
Okay. If you have no other question. Okay, thanks so much. I remember also for you, not for my students, that in August 1944, near the high port of New York. At the time, it was named Fiorello LaGuardia. A 5-star general, Hap Arnold, met very famous at the time scientist Theodore von Karman, international specialist of aerodynamics, and invited him. He said him bye-bye because he was spent in Europe to contact his colleagues from European countries, and particularly also in Germany. And in this mission, Theodore von Karman was with Dryden. Professor Dryden was one of the founders of GPL, Jet Propulsion Laboratory in Pasadena. And with them, also in US Army uniform, both professors were in US Army uniform. There was also a young Chinese student, the name was Tian. And Tian in 1956 was obliged to leave USA and to came back in China. And in the 1960s, he started the Chinese space program. And he got also a photo with Mao Zedong. In 2003, Space Week, Aviation Week, has a very important special issue with the image of Tian, the aged Tian. Why? Because Tian is the father of China's space program. I quoted in my lesson this example because this example is a part of a long-term strategy designed by USA to drain brain in USA, is also continue during all administration, but this strategy started at the end of the Second World War, also with Italian scientists. You have, for instance, Antonio Ferri, a performing scientist in Guidonia Center, near Rome, and he was invited to arrive in USA, and several other scientists like Gerardo Napolitano, the father of European microgravity studies, and also Bepi Colombo go in USA, in MIT, for instance, to study and came back in Italy. This is a great influence diplomacy, perhaps at the time cultural, but today this is also one of the most relevant targets in science diplomacy. As you know, and I finish here, some European countries, Italy, France, and European Union, launch programs to invite US scientists to come in Europe in the present day, because perhaps, maybe, or this is the reality, the present administration had some new plan for research, and particularly a serious cut of financement, and also perhaps a desire a more oriented research. For this reason, Europe invited these scientists to come and to participate in our research. Last but not least, we must quote a European program born, frankly speaking, United States, and our university is a part in this program. Scholar at Risk is a program to invite colleagues coming from dictatorship or no democratic states around the world. This is another example of science diplomacy. Thanks so much for your attention. We have recorded your participation in our seminar. Thanks so much. And I remember you that you have attended, frankly speaking, a sort of esoteric 2 days, because we have here in person political science students and you are specialist in space studies, but for us it's very important to share with our student here and with you this approach, this real interdisciplinary approach. For this reason, we want to stay in touch also with all of you, and if you want, we may share dialogue and drink some wine in June in our PhD day in Palermo, and share ideas and also perhaps participation in our research. Grazie molte per l'attenzione, la partecipazione, è stato un piacere e spero che ci vedremo appunto nel PhD Day a Palermo. Ringrazio anche gli studenti in aula per la pazienza, perché non sempre è semplice affrontare argomenti tecnoscientifici. Grazie, arrivederci.